In this video, I'm going to show you two things. One is how to calculate either the hydronium ion or hydroxide ion concentration, and then figuring out pH. So there's two equations, and these you get in your reference packet, and you get them on the test. You have 1.0 times 10 to the minus 14th equals the hydronium ion concentration. Now sometimes that is written as hydrogen ion concentration. Now either way, that is like the acid portion multiplied by the hydroxide concentration, which would be like the base portion of it. And pH is negative log of hydronium ion. It has to be the hydronium ion. One of the mistakes people make if they're going too fast is they do negative log of hydroxide. That does not give you pH. That gives you something else called pOH. 1.0 times 10 to the minus 14th, that is a constant. It is the equilibrium constant for water. It is never going to change. We will use that in our equations. What happens if you have pure water at 25 degrees Celsius, you get equal amounts of hydronium ion and hydroxide ion concentrations, and they would both be in there at 1.0 times 10 to the minus 7th molarity. So when you multiply those two, that's where we get this 1.0 times 10 to the minus 14th, and that is why we use that as this constant. So for this first problem, it is asking for the hydronium ion concentration of sour pickles. It gives us the hydroxide ion concentration of 1.6 times 10 to the minus 11th molar. So we take this first equation here and we rearrange it for hydronium. So what you get is hydronium ion equals 1.0 times 10 to the minus 14th divided by the hydroxide ion concentration, which we give you as 1.6 times 10 to the minus 11th. Now, before I even do any math on this, if I look at this hydroxide ion concentration, it's 1.6 times 10 to the minus 11th. That is a pretty low number for hydroxide ion, and hydroxide is the base portion. So if I have a low number for the hydroxide portion, the base portion, I should expect some larger number for the acid portion. So overall, I'm going to expect these pickles to be on the acidic side, which would be a pH lower than 7. And we know that acids taste sour, and that's another kind of hint here. So by the time we get to the end, we should end up with a acidic pH, or something less than 7. When I do this on the calculator, I get 6.3 times 10 to the minus 4th molar. Now, since all I'm doing is a division here, I match up the significant digits the same way I always did. There's two significant digits in this number, so I round my answer off to two significant digits. Never use the equilibrium constant, this number, for significant digits. It is a known value. There's no uncertainty, so it has an infinite number of significant digits. So use the number of the problem. Alright, so this is what I get after I round it off to the right number of significant digits. Now, the pH. Remember, pH is negative log of hydronium, and that is what I solved for. So in this one, I am going to take negative log of 6.3 times 10 to the minus 4th. And when I do that in the calculator, I'm going to round that off to 3.20. What's different about this now in significant digits, since we are doing a log here, and logs are based off factors of 10, we have to change the way we do our significant digits. So since this is two significant digits, the way we do it now when you're doing logs is however many number of significant digits you have here, that's how many numbers you should have after the decimal point. So two significant digits, two numbers after the decimal point. And the pH is less than 7, so they are acidic. And like I said, that's what you should have expected from the beginning. Your hydronium ion concentration is a lot more than your hydroxide ion concentration, and hydronium is like the acid portion of it. Alright, so that's the first one. The next problem is set up a little different, although it has the same general idea. The next one is, I give you the hydronium ion content of some soft drink. The hydronium ion is measured to be 2.43 times 10 to the minus 6 molar. It wants to know the hydroxide ion concentration in this problem, and then the next one we will do the pH. So we rearrange that first equation that was at the top of the page. You take the equilibrium constant for water, you divide that by the hydronium ion concentration, which is 2.43 times 10 to the minus 6. what you get when you round it off, since this is 3 significant digits, I'm going to round my answer off to 3 significant digits. I get 4.12 times 10 to the minus 9th molar. Alright, now, when I look at this, the hydroxide ion concentration is less than the hydronium ion concentration, right? Hydroxide is to the minus 9th, hydronium is to the minus 6th. I should expect this pH to be on the acidic side, because I have more hydronium ion. Now, this is the part where people get confused sometimes. In the first problem, I took negative log of what I solved for, because I solved for the hydronium ion concentration. In this one, that is what I gave you. Alright, so that's what I'm going to take the negative log of. 2.43 times 10 to the minus 6. Rounded off, I have 3 significant digits, so I'm going to need 3 numbers after my decimal point, so I'll round that off to 5.614. Right. And that number is less than 7, so again, that is acidic. That is a general idea with these types of problems.